Alright, so in the previous working, we calculated the total resistance in this circuit. Then from that, we calculated the total current. Now, the total current IT is a sum of the currents through these branches. Conventional current would flow into each of these branches. So we would have the total current right here, splitting, some of it splitting first going to I1, then after some has split and gone to I1, some would then travel, the rest would travel here. So the total current minus what goes to I1 would travel here. When it reaches this junction, some of that will go to I2 and then the rest that is left will go to I3. As it travels around, the current from I2 and I3 will meet at this junction, travel down here to meet with I1, and then we would get the total current being here again. Now, we can actually find the individual current in each of these branches. How do we do that? We go back to Ohm's law. So we can use Ohm's law to say that the total voltage in a particular branch is equal to the current in that branch times the resistance in that particular branch. So here we have the resistance in the branch and we have the voltage that would be fed to this branch, but we don't have the current. So we would have to manipulate Ohm's law in order to find the current in that branch. What we would use here is the voltage going to the branch and the resistance in that branch. So we could not use the total resistance here in the circuit. We would have to use the resistance that is particular to that branch. So let me see the value for the resistance that I have here. And in doing all of this, we have to remember that voltage is constant in a parallel circuit. So the resistance I have here is 14 ohms. So let me see which branch do I have 14 ohms in. So this third branch is what I have my 14 ohms resistor in. Therefore, the current value right here, 6 volts over 14 ohms, is gives me 0.43 amperes. So 0.43 amperes is actually going to this third branch here. Now, in order to find the current through I2 and I1, I would simply use the same formula. The voltage would remain constant, but I would have to use my individual resistances. So instead of 14 for I2, to find I2, I'd have to use 3 ohms because that's the resistance in that branch. I would get 2 amperes as my answer. So I put my 2 amperes here. When I use 7 over 6 volts for I1 in the first branch, I am going to get 0.86. If I add 0.86 plus 2 plus that's 0.43, I believe. Yes, I am going to get back my total current. So when all of these are added, I get back my total current, which we calculated was 3.28. I believe I really get 3.29 here, but it's because of rounding off these values. But we still get back approximately the same total current.